And now I will introduce Eugenio Fraile, Dr. Eugenio Fraile, with his talk. So I will present him. He's a physical oceanographer for the University of Las Palmas de Gran Canaria. His PhD obtained the extraordinary prize for the best doctoral thesis in experimental science area. Since 2009, is the researcher at the Spanish Institute of Oceanography. Here we are at the Oceanographic Center in the Canary Islands, Tenerife. His research on climate changes focuses on the variability of the thermohaline properties, heat and mass transport of large-scale ocean processes. So just he has accumulated over 1,500 days at sea at different national and international research vessels around the world, and he's currently the physical oceanographic leader of Vulcana project. This is the reason we're here in the VulcanaSymposium, for the study of the variation of the physical-thermal, chemical, biological, and geological properties due to submarine eruption and hydrothermal vents in the Canary Islands. So let's begin the talk. Physical, chemical perturbation and biological response over the two most recent eruptions registered in the Canary Islands, Tagoro submarine eruption and Cumbre Vieja, La Palma.
Thank you so much. So thank you everybody to be here today. I have just 20 minutes in order to explain a little bit what we have done, our institution we have done in the submarine volcano eruption at El Hierro Island and in Cumbre Vieja, La Palma. I have to tell you that this is not a work just from the Spanish Institute of Oceanography, but it's also with a lot of institutions, both the University of the Canary Islands and IGN, Geological, IGME, and IPNA-CSIC and a lot of the University of Salamanca, etc. So it's a multidisciplinary project, and we are going to try to explain just these 20 minutes. So we're going to start for Tagoro submarine volcano. So in order to speak about Tagoro submarine volcano, you have to go back in time to July 2011, where between 10,000 or 15,000 earthquakes were taking place in the island of El Hierro. As Itahiza said before, finally the ocean crust broken here at 1.8 kilometers south of the village, La Restinga village, starting the magmatic activity. As you can see here, the submarine volcano was emitting a lot of molten material to the ocean, temperature, heat, gases, sulfur, ion, etc. to the ocean. That became a lot of physical-chemical anomaly that you can see also via satellite. Here is the coloration of the ocean was enormous, and you can see here a big magmatic plume, a toxic plume that were covering not only the south part of El Hierro Island, but also the west part, the north part. In some occasion also touch another island. Here is La Gomera, and with the interaction with the mesoscale activity and the current of the Canary Island, this magmatic plume was drifting with the current more than 100 kilometers offshore. Here you can see also the evolution of the magmatic plume via satellite, and here you can see the interaction also with an anticyclonic eddy drifting 100 kilometers far away from the island of El Hierro. Our institution, together with all the other institutions, we were doing a huge monitoring in this event. We started with in 2011 with Project Bimbache, and we continue today. So we were monitoring this area for more than 11 years right now, with more than 32 oceanographic cruises in 11 years. We sent our ship, Ramón Margalef in that case, and later Ángeles Alvariño, in order to monitoring for the physical, chemical, biological, and geological point of view all these variables over there. Our role, in the same case of Itahiza and Nieves, Sánchez, and etc., was not only do science, but also to advise the government, no? And the PEVOLCA, of course. We are part of the PEVOLCA also. From the physical point of view, we were using our rosette in order to take samples of the whole column water. We were measuring the whole water column from the surface to the bottom of the ocean with different sensors of temperature, conductivity, pH, oxygen, etc., and taking water sample in situ in order to analyze from the biological and chemical point of view. Also, our chemical oceanographic were obtaining sample of the dissolved oxygen, dig, inorganic nutrients, pH, alkalinity, POC, metal. As you can see, there's thousands of different properties that we were measuring in the area for all these 11 years. Also, the marine geology, we are taking samples together with Antonio from the University of Sal, our friends from Malaga, Cádiz, etc. Here you can see the face of our colleague Nieves Sánchez, Nieves Lopez, sorry, taking all these rock samples, bathymetry, morphology of the study. We also did a collaboration with the Instituto Hidrográfico de Marina, our army, in order to put this bathymetry. We first did the first bathymetry of the submarine volcano Tagoro. Finally, it's in our cards, is here, and submarine volcano Tagoro, it has already the height of the Empire State Building in New York. It's almost 300 meters high, 1 kilometer diameter, 14 secondary craters, and the upper crater is 88 meters below sea, so only 88 meters to become a new island in the Canary Archipelago. And also the main crater, the more active crater, is 127 meters below sea level. We also use our vehicle, remote operate vehicle, or ROV, in order to take imaging of high quality of the different cracks, bends in the area, but also to take our water sample with this special tool, directly for the bends, or to take water samples, or to take sediments, haloclastids, everything inside the water. But also we used the mini submarine, the Diego, with the collaboration of Geomar, so we could go inside the volcano, inside the crater, in order to see in person and to take samples. And it's coming soon that you know that there's a new submarine here in the Tenerife that is one of the 5th submarine that can reach more than 2,000 meter depth. So it's Pisces 6 and it's here in Tenerife. So we are using to go coming really soon to the Tagoro submarine volcano and the lava delta at La Palma. So with all this information, we were doing what we do is science, and to publish this science in the best magazine as possible. So I'm gonna explain you a little bit more about the more important article that we were published. One of them said that the marine ecosystem of El Hierro Island is a natural laboratory and is supporting the 3 stressors of the climate change. As you everybody know, the 3 stressors of the climate change is temperature increase, ocean acidification, and desoxygenation. So the first stressor, temperature increase, normal climate change model predict that for the next century, the temperature of the ocean is going to increase about 0.6 degrees Celsius per century. What was the temperature that were increasing in the submarine volcano eruption during this month? So 18.8. So you can see the face of our physical oceanographer Veronica is stunning. It's a really big temperature for the water. And you know that the capacity of the heat capacity of the water is 4,000 bigger than the atmosphere. So it's a lot of heat over there. Another one, the acidification model predicted that for the next century it's going to be a decreasing of the pH around 0.3 units. So the marine ecosystem or El Hierro Island were suffering a pH acidification, an anomaly of the pH of more than 2.8 unit. But not only this, the sulfur that in normal condition is nothing, is 0. We found there between 50 and 100 micromole of sulfur of the CT, the total carbon was 400% higher than the normal condition, or the ion is 4 million times higher than the normal condition, and the PCO2 that the normal condition is just around 380 microatmosphere. We were reducing more than 300,000 microatmosphere in the area. No? And finally, the oxygenation. No? You know that the climate change also predict that for the next century, the decreasing of the oxygen in the whole column water is going to be around 0.7. But we have a decreasing of the oxygen more than 97% in the area. So you can see there was anoxic, complete anoxic in the area. So here you can see also, I'm going to change my hand. Here you can see an echogram of our ship, where you can see from surface to the 800 meter the normal distribution of the column water. Here you can see a mixed layer, and here you can see the deep scattering layer. What's going on where we approach to the ocean? So you can see there was a disruption of this deep scattering layer going up, no? So there was a perturbation of the migration due to the high concentration of ashes here that reduced the penetration of the light, but also the mixed layer disappeared completely. Why? Because of the anoxic layer that were due to the reduced component of sulfur and iron that were consuming all this oxygen. And this was the main reason why we localized a lot of dead fishes on surface. You know? But not only the dead fish, but also the phytoplankton and zooplankton were decreasing. Yeah, you can see here one of our publication at 75 meter depth, the abundance of Prochlorococcus and Synechococcus, that you know that this is an organism that produces more than 50% of the oxygen that we are breathing in the atmosphere, that they reduce about 3 and 2 orders of magnitude respectively. No, but also another team of the IEO, together with another institution, they found out or discovered a new bacteria worldwide in the Tagoro submarine volcano. That is this white filament over here is a Thiolaba veneris. So, and we are trying to in vitro cultivate these organisms here in the institute. The two will be here, and we'll explain them later. This about that. But the submarine volcano at the first time was doing a really huge perturbation, dramatic perturbation, but also they were emitting, not only in this period, but also 11 years later, they are still emitting to the ocean a huge quantity of nutrients and iron in order to make the regeneration processes really high, in a really high rate. So this is how nature works. It's a big perturbation at the beginning, but later, right now, we've got a marine ecosystem even with more diversity and richness than before the volcano. And here you can see in the whole water column all the nutrients that were emitting. I don't know if you can see here in this green line, but it's around 200 micromole kilo. So the different nutrients injecting directly to the photic level, and also the iron. What's the physical anomaly right now? They are still present in the area. They finished, as can say to you, that with our monitoring, we go every single year from 2014, 15, 16, 17, 20, 21, sorry, I didn't put the 22, but also I've got it. So you can see here with this different Toyo transit, this is the summit of the main crater, and this is the 400 meter depth. So we're doing with our rosette, putting up and down in the whole column water from here to there. So you can see this is south, this is north. And once we approach to this area where the submarine volcanoes are active, you can see that the sensor start jumping. No? This is a pH more than 0.6, so it's active, it's still active. So here is I love this picture because it's like a book picture where you can see that the pH is decreasing, the ORP is decreasing while we were close to this area. The turbidity is increasing and the temperature is also increasing. So you can see that perfectly match all the variables once we approach to the anomaly area. And so it is active and it's still active. So for this reason reason we are still monitoring this event. I can not move there. Okay. Could you touch the screen, please? Could you touch the screen in order to touch? Okay, thank you. So also we are able to put a mooring inside the crater. This is the main crater. So this is a mooring that we put over here to take samples in a really long time period, not only during our cruise, but also for 3, 4, 6 months, taking with the temperature, salinity, seismometer, everything there. So this is the way we deploy the mooring, and this is when we recover it. So you can see the difference between the two of them now, because of the huge quantity of iron. So this is our result. So the volcano at 2 meter high of the band is supporting every single time more than 2.5 degrees, decreasing of salinity of 1 point, decreasing of the density, and for sure decreasing of the pH for more than 1.20, more than 25 units. Oops. Okay, so I think I jumped. Okay. So now let's talk about the Cumbre Vieja volcano in 2021, when the Spanish Institute also was involved. And we were there with our ship, Ángeles Alvarinho, 1 week before the lava touched the ocean. So this work was also doing with a lot of institutions that were able to go with us in our ship in order to monitoring the submarine ambient before and after the lava reached the ocean. Our main objective was 3 different main objectives. The first one is the physiographic and morphologic characterization of the seafloor associated to the well, in the southwest of the lava of the La Palma area, and with a special attention to the growth of the lava delta. This point is going to be explained in more detail for our colleague Juan Tomás Vázquez from IEO in the next talk. But the second and the third objective, I am trying to explain a little bit about the study of the physical, chemical, and biological property of the whole core water, and also the impact of the eruptive process in the planktonic and bentonic community that also Chechu and Claudia is going to speak a little bit about that. Okay, yeah. So we were there for more than 48 days evaluating this impact with our ship. Our ship was open, I told you, to everybody and every institution. This is the first, the lava touched the ocean on the 28th of September at 28 hour UTC. This was the first arrival of the lava to the ocean, and you will see these astonishing images where the lava was forming the lava delta. It was really difficult for us also to work in this condition as in the earth. We need to take protection also in order to avoid the toxic gases inside and outside of our ship. And this is the growth of the lava delta, not only in the surface but also inside the slope of the ocean, and reaching more than 300 meter depth, and with more than 1.5 kilometers far away from the coastline. This is going to be explained by Juan Tomás Vázquez a little bit later. And this is how we take samples in the ocean with our ROV. We are taking samples of sediments, corals, rocks, etc. And take samples of for example, this mega pillow. No, this is a new generation. It's one of the youngest mega pillows on Earth. It's only 1 year right now, but at this moment it was just a few days. No? You can see here how we work. So it's trying to almost 300 meter depth, try to obtain the ashes and hydroclast data in order to analyze the components of this material. Okay, so I've told you before, the collaboration with different institutions is really high. Here, there's some areas of the lava delta that we were not reaching with our ship, because we have to take a limit of security to our ship. So we were not possible to penetrate more than 200 meters once the lava delta was active. So we need to do several to use another tool in order to measurement this. So we use drone. This is a project that we did together with IGME-CSIC. We are going to have another talk at the end of the day with Alejandro Roman, that he's going to explain this magnificent job also. So we were also able to obtain not only water samples with a drone, but also the morphology of the lava delta and the temperature of the ocean. Also collaboration with the Instituto Geológico y Minero de España. They came on board and with this experience, so we were able to identify all the rocks inside the ocean. And this is from the physical chemical point of view of the Itahiza said before. We know for the model more or less where the lava is going to reach the ocean if finally touch it. So we were 1 week before the lava touched the ocean, just doing our background study over there. So we were monitoring the physical chemical anomalies here, or properties here, before the lava touched the ocean. You can see here temperature and salinity. In blue is before the lava touched the ocean, and in red is when the lava touched the ocean. And you can see here in yellow the proximity of our ship to the lava delta. So once the lava touched the ocean, you can see this peak here that is really close to the lava delta. So, but also 500 meters far away. So you can see a temperature anomaly of the temperature increase of 28 degrees. That is a lot in 500 meters far away from the lava delta. But we could reach also 50 degrees close to the lava delta. No? So the physical processes that we were seeing in this area, in the same way that in Hawaii, Wilson and Resin saw before, is once the lava is going down for the slope, no, is a physical process that is upwelling. No, this water is heating, and so it's going up. It's less dense. So it's a physical process that is an upwelling. So it's injecting a nutrient from the deeper parts to the shallow part. So in this occasion, they saw a production or a bloom of phytoplankton in surface. So we wanted to see if this was happening the same in La Palma. So we did also this transect, no, and in order to see if these processes were doing this high productivity. And what we saw is that here you can see the density, salinity, temperature, oxygen, everything. And this is a Toyo, this is a lava delta, and this is open ocean. So you can see here going up and down. This is our rosette in order to have a picture of this water column. And we can see here also the upwelling process was present. No, this is you can see the moving up of the isopycna, isothermal, whatever you can see here. So, and you can see also in the whole water column, not only in surface, in this yellow line, this is the different sensor with from surface to the bottom, and you can see the anomalies in surface, but also anomaly in the whole column water in this line. No, the turbidity was affected, the ORP, the pH, the oxygen, the salinity, the temperature, etc. So and one of the main problems was the huge quantity of ashes in the surface of the water in the whole area. Not only the ashes that was present in the sub area part, but also in our ship. You can see here. Now you cannot see our ship because it's completely full of ashes, and also every single sample of water that we take from the water, it was completely full of ashes. And you can see also delta offshore, a huge perturbation of ashes and hydroclastic, not only in surface. Here you can see a big penetration of the plume to the 15 meter or even in the deeper part. So what is the perturbation between marine life of these ashes? So this is turbidity section, you can see here the fluorescent, and you know the fluorescence is similar to chlorophyll and similar to identify how is the phytoplankton or organisms over there. That is the first level of the trophic chain. So I don't know if you can see here, there was a perturbation between the fluorescence and the chlorophyll. Okay, so if we are able to eliminate this this problem, here is the fluorescent. We also take sample of chlorophyll in order to do the regression and to convert into chlorophyll. But I'm going to show you just the fluorescence. This is the integrated fluorescence between 0 and more than 150 meter depth. So in normal condition, before the lava touch the ocean, this is the normal situation that you can find in the area. So this is the far field station. This is our control, and this is the integration. This is the chlorophyll of the fluorescence that should be in the normal area. If we get closer, 1.5 kilometer or even 1 kilometer to the coast, normally the chlorophyll is going to increase. So this is not normal, perfect, it's going to increase. What happened when the lava touched the ocean in September 2021? So something was changing in the column water also. No? So this is also our far field station, was more or less the same that before, but when we were closer to 1.5 kilometer, it was a reduction of the chlorophyll, and also when we were really close to 1 kilometer, have you seen the diminution of the concentration of chlorophyll or fluorescence? And in October 2021, the decreasing was also more evident. So we were finding that a decreasing of more than 48% of the phytoplankton in the ocean at this level. I cannot. Could you touch the screen, please, Sharon? Thank you. And also at the same at El Hierro Island, we found several fishes dead in surface, but in this occasion it was not for the decreasing of the oxygen, was for the increasing of hyaloclastitis and ashes that couldn't breathe, and was a problem of stuck the brain, and also a collapse of the marine ecosystem due to this huge quantity of ashes. You can see here, no? A little crab completely full of ashes walking around the area. No? But I would like to, and this is my last slide, may this imagine serve to give a stretch and hope to the inhabitant of La Palma, because Mother Nature is wise, and this is the beginning, so that the marine ecosystem lava will soon be fully recovered. And this is one of the first organisms that were covering this new lava area. So thank you so much for attending.
Well, I think one quick question.
Yes, so it looks like you had increased productivity from ashfall as well as upwelling induced from the lava flow. Were you able to differentiate between the two? The blooms produced by either the lava delta, as seen in Wilson in Hawaii, and then also you had ashfall. Were you able to differentiate?
So different kind of volcanism in Hawaii that in La Palma. So there's we've got a really big problem in La Palma, not only to ashes that were on the surface of the ocean, and decreasing the light penetration. No? Okay, so this was the main reason why the photosynthesis couldn't be done, and we have a really huge decreasing of the productivity in our area. No? In Hawaii, that was not possible. That there's no ashes at all in surface, and the welling system was injecting nutrient from the deeper part of the ocean to the surface water. That's the main reason. So